A little introduction is necessary for those unfamiliar with Assassin's Creed. In the image shown, the guy wearing the black hood and red cape is the player. All of the men standing around him with red arrows over their heads are soldiers. The red arrows represent that the soldiers are aware of the player's presence and are hostile. Normally, soldiers have no arrows over their heads, which means that they are unaware of the player. In certain situations, when the player escapes from the soldiers, the arrow is yellow to signify that the soldiers are alerted to the player's location, but are unable to find the player. Now that the explanations are out of the way, the following scene should make some sense. Video games are generally responsible for pushing the envelope in terms of real-time personal computing. This clip is fairly outdated, but it is still apparent that the graphics are really good. The world is fairly expansive, and the AI is completely inept. While this scene is quite comical the first time around, it is significantly less exciting the 10th time around, and even less so the 100th time around. The problem is that the AI is completely static. This is a problem because it provides a significantly less immersive experience to the player, but also because it shows that video games are not even attempting to improve artificial intelligence and pioneer the way to new techniques and algorithms in the field, as they do in other fields. This AI can be broken down into a simple state machine, with 4 states as shown here. The boxes represent the different states, and the words inside each state represent a basic stateless AI, that is, a decision tree, that controls the state. The arrows can be thought of as functions that get input from the agent's senses and are followed to the next state when true. This AI is extremely simplistic and allows no room for real intelligence and learning. On the other hand, this home-cooked solution shows a basic genetic algorithm that seeks to learn by replicating natural selection. The numbers represent all of the individual agents and how fit they are. Think Darwin and survival of the fittest. The goal of the simulation is to get the agents to move in a circular motion on the white tiles. It is immediately apparent that even in this trivial example, where only 8 different movement actions are available, the algorithm takes a significant amount of time that would make it infeasible for any real-time system. The majority of the algorithm was cut from the video, but in total, it took over 6 minutes to reach convergence just in this simple case. The solution to this problem is to combine both of the previous 2 solutions. The state machine from the Assassin's Creed AI should be used in conjunction with an intelligent algorithm, such as a genetic algorithm. The state machines will provide a functional basis for all agents generated, essentially a skeleton of how to move and how to react to very basic stimulus. The intelligent algorithm can then be applied on top of this skeleton. The algorithm will seek to adapt the agent to the environment instead of trying to generate the basic skeleton of the agent. In this manner, the algorithm will generate unique quirks for each agent, and that will serve to differentiate it from otherwise identical agents. Additionally, if the algorithm is unable to generate any valid results in the time allocated, the state machine skeleton can simply be used to control the agent. The agent will be very simplistic, but still functional. In this manner, intelligent algorithms can be used to make similar agents behave in a novel fashion, thus making gameplay more immersive. More importantly, it will open up the field of artificial intelligence to game developers and hopefully result in pushing forward research and development in the field, especially as it relates to developing intelligent agents given a strict time frame.